everyone, welcome to my department of Sohmur High School. It is the first session of Chapter 17, Permutations for the second secondary classes. Objectives of the first session are 1. To introduce a best way of counting. 2. To arrange n objects among themselves. 3. To practice some applications concerning these objectives. Let's start by fundamental counting of principle. If a job is performed by n ways and another job is performed by m ways, then the total job is performed by n times m ways. Direct application to clarify what we are talking about. Sammy owns 4 shirts and 2 pants. Question number 1. In how many ways can Sammy wear a shirt and a pant? In how many ways do you think Sammy can wear a shirt? It is obvious. Sammy can wear a shirt by 4 different ways. He can wear the first, or second, or third, or fourth. Same question here. In how many ways do you think Sammy can wear a pant? Sammy can wear a pant by 2 ways. He can wear the first one or the second one. Now main question. In how many ways do you think Sammy can wear a shirt from one side and a pant from the other side? This situation now is a direct application of fundamental counting principle. Then the total ways will be 4 times 2 equal 8 ways. And so Sammy can wear a shirt and a pant by 8 options. Pay attention, and is called a golden rule of counting, which is always means multiplication. Whenever we have and, we multiply the options. 2. List all the ways. For this, we name the shirts as S1, S2, S3, S4, and the pants as P1, P2. Now listing all the options by a tree. Sammy has 4 choices to wear a shirt. Sammy can wear S1, or S2, or S3, or S4. In the case Sammy wear S1, he has 2 choices for a pant. He can wear P1 or P2. In the case Sammy wear S2, he has 2 choices for a pant. He can wear P1 or P2. Similarly for S3, similarly for S4, we have other 2 options. Then the total options are Sammy can wear S1, P1, S1, P2, S2, P1, S2, P2, S3, P1, S3, P2, S4, P1, and the last one, S4, P2. And the number of options, again, are 8 options. Another application. We have 3 pens, 5 pencils, and 4 books. Given that every item is distinct, no 2 items are the same. Question number 1. In how many ways can we choose any one item out of the 12? A pen can be chosen by 3 ways, a pencil by 5 ways, and a book by 4 ways. Now one item may be chosen to be a pen or a pencil or a book. For a pen we have 3 ways, for a pencil 5 ways, and for a book we have 4 ways. Then we can choose one item out of 12 by just 12 ways. Pay attention. Or is called a golden rule of counting, which is always means addition when we have or we add all the ways. Start by part 2. In how many ways can we choose one pen, one pencil, and one book? Start by solution. One pen can be chosen by 3 ways, and one pencil by 5 ways, and one book by 4 ways. Now apply fundamental counting of principle. Multiply all the ways. Then the number of ways will be 60 ways. 60 ways now. is the number of all options in which we can choose one pen and one pencil and one book together. Let's start by new slide. Number so that n greater than or equal to 1. We define m factorial to be the product of the first n consecutive natural numbers, and it is denoted by n factorial. This symbol or notation is called factorial. What is the value of n factorial? It is just multiplied n by n minus 1, multiplied so on by 3 by 2 by 1. Without writing each time this product, it is abbreviated by n factorial. By convention, 0 factorial equal 1 and 1 factorial equal 1. Example number 1. 2 factorial, 2 times 1 equal 2. 3 factorial, 3 times 2 times 1 equals 6. 4 factorial, by definition, it is just a product of the first 4 consecutive natural number. This is why 4 factorial will be 4 times 3 times 2 times 1 equal 24. And the last example, 5 factorial, 5 times 4 times 3 times 2 times 1 equal 120. You may use a calculator to find a value of any one of these numbers. Definition. A permutation of n objects among themselves is any arrangement of n objects. Objects may be letters, numbers, persons, and so on. Of sure order is very important. Introduction to understand well what do you mean by this definition, and essentially by a word, order is very important. List all words of 3 different letters that can be formed out of the given letters C, A, and T. A word does not necessarily have a meaning. Given the letters C, A, and T. If C is the first letter, then A and T can be arranged by 2 different ways to get the options CAT and CTA. Pay attention here. CAT itself is a word cat. CTA, this word has no meaning. In this situation, we say order is important simply because these 2 words are different. Now complete. Assuming C is the second letter, again A and T can be permuted by 2 ways to get another option, TCA. Assuming C is the third letter, then A and T can be permuted to get other 2 options. Then the total number of words equal to 6. Now, what does 6 means? 6 is just 3 factorial. Important question now. Can we expect the property to arrange n objects among themselves? Of sure. The number of permutations of n objects among themselves will be n factorial. Example, given a word OK, then OK and KO are the words of 2 different letters formed out of the word OK. Application, arrangement of letters. In how many ways of 4 different letters can be formed out of the letters R, O, S, E. In all cases, word does not necessarily have a meaning. Solution. In this situation, we have 4 letters and we are going to arrange these 4 letters among themselves. This is why can be arranged by 5 factorial. It is just a direct application of this property. The total number of words equal 24. We will display some outcomes to understand well what we are talking about. One of these options is a word rose itself. Another option, ROES, take care, order is important. They are different. ORES and ORSC are some arrangements Order is important, as I mentioned now, since a word rose and R-O-E-S are two different words. Let us complete. Activity. Arrangement of numbers now. Part 1. In how many ways 3 different digit numbers can be formed out of the digits 1, 2, 3. Part B. List all these 3 different digit numbers. Solution. The 3 digits 1, 2, 3 can be arranged among themselves by 3 factorial. Pay attention. To arrange n objects, we have n factorial way by this property. Then to arrange 3 numbers, we have a 3 factorial way. The total options equal to 6. Part B. List all these options. First of all, if 1 is the hundredths digits, then 2 and 3 can be arranged by 2 ways to get the numbers that are different. 123, 132. Assuming 1 is the 10th digit, then the numbers are 213, 312. Now assuming 1 is the units digit, again the numbers are 231 and 321, and in this case the number of options equal to 6. Complete. B. How many 4 different digit numbers can be formed out of the given digits 1, 2, 3, 4? In a part 2, we have 4 digits. First solution, which is very important, technique of slots. We may consider a 4 different digit number as a form of 4 slots, first, second, third, and fourth. Now listen to me carefully. The first slot can be filled by 4 ways, simply because any one of these numbers can be filled in this slot. Once this has happened, then the second slot has a remaining of 3 numbers, and so on. Once first and second are already filled, then the third slot has a remaining of 2 and just 1 way for the last slot. This is why the total possible outcomes is just 4 by 3 by 2 by 1 equal 24. Another method. In order to permute 4 numbers among themselves, we have 4 factorial ways. Then the total number of options is just 4 factorial, again equal 24. New application, arrangement of people in a row. Given 3 persons, Sami, Farid, and Zahi, and we have been provided by 3 chairs on a straight line. Question number 1. In how many ways can 3 persons be seated on 3 chairs on a row? Solution of part 1. It is very easy. 3 persons can be seated on 3 chairs by 3 factorial ways. Then the total possible outcomes equal to 6. Part 2. List all these possible outcomes. Assuming Sami is seated on the first chair, then Farid and Zahi can be arranged by 2 ways to get Sami, Farid, Zahi, and Sami, Zahi, Farid. Now assuming Sami is seated on the second chair, then Farid and Zahi can be arranged on these 2 chairs by 2 different ways to get the other options, Farid, Sami, Zahi, Zahi, Sami, Farid. Now assuming Sami is seated on the third chair, then the options will be Farid, Zahi, Sami, and Zahi, Farid, Sami. Again, we have 6 options in a way that 3 persons can be seated on 3 chairs. Another application. Arrangement of people. Given 5 people and 5 chairs on a row, in how many ways can these chairs be occupied? First method, technique of slot. Assume the 5 chairs are like 5 slots: first, second, third, fourth, and fifth. Now, what about the first slot? First slot can be filled by 5 ways, simply because any one of the 5 people can be seated on the first chair. And since this has happened, there is a remaining of 4 people. This is why the second chair can be filled by 4 ways. Now, once the first chair and the second chair are been occupied, then there is a remaining of 3 people, and this is why the third slot can be filled by 3 ways. Similarly, the fourth one by 2 ways that are the remaining people, and we have just 1 way for the fifth slot. Now, applying fundamental counting principle, multiply all these options to get the total possible ways equal 120. Second method, it is very simple. We may say 5 people can be seated on 5 chairs just by 5 factorial, which is again 5 multiplied by 4 by 3 by 2 by 1 equal 120. Last application. 3 boys and 2 girls want to sit on a bench. Part 1. In how many ways can they sit in any order? Let's start by solution of 1. It is obvious that 5 persons can be arranged among themselves by 5 factorial. Then the total number of possible outcomes equal 120. Part 2. In how many ways can they sit under these conditions? A. 3 boys are together and 2 girls are together. B. 3 boys are not separated. C. In alternating seats. Let's start by solution of 2A. Given that the 3 boys are together and the 2 girls are together, then we have 2 choices: boy, 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 girl, girl, or another choice: girl, girl, boy, boy, boy. Now, what about 3 boys? 3 boys can be arranged on their seats by 3 factorial, and the 2 girls can be arranged among themselves by 2 factorial. Similarly, for this choice, 2 girl, 2 factorial, 3 boys, we have 3 factorial ways. Then the total number of ways will be 12 plus 12 equal 24. 24 is the total options in which 3 boys are together and 2 girls are together. We have not finished yet. We still have listing of these ways. Call the boys B1, B2, B3 and the girls G1 and G2. Start by listing all the options. Assuming B1 in the first seat, then B2 and B3 can be arranged by 2 different ways. Don't forget the girls are together. Now assuming B1 is seated on the second seat, then permute again. Now assuming B1 on the third seat, again permute B2, B3, and we have a list of 6 options till now. Now permute G1, G2 into G2, G1 and repeat the same procedure to get other 6 options, and now permute G1, G2 from the 4th and the 5th seats to the 1st and to the 2nd. We'll get this option. Now P1 is seated on the 3rd seat, permute P2, P3, P1 on the 4th one, P1 again on the 4th one. Now P1 on the 5th seat, again permute. Now repeat all these options, but now permute G1, G2 into G2, G1 to get another 6 options. Again, the total number of options equal 24 ways. Let's complete. Part B. Given that the three boys are not separated, in this situation we have three options. Three boys, then two girls. Second choice, the boys are seated on the middle seats and the girls on the first and on the last. Third choice, girls then boys. Now what about three boys? Three boys can be arranged among themselves by three factorial ways. Two girls by two factorial way. For the second choice, the three boys among their seats can be arranged by 3 factorial, and the two girls among their seats can be arranged by 2 factorial. Again, similarly for the third choice, then the total ways will be 12 plus 12 plus 12 equal 36. Now part C. Given that the boys and the girls sit on a bench in alternating seats, it means neither boys next to one another nor girls next to one another. In this case, we have only one choice. They can be seated in this way: boy, girl, boy, girl, boy. Now, the three boys among themselves can be arranged on their seats by 3 factorial, and the girls among themselves can be arranged among their seats by 2 factorial, then the total ways equal 12. Important remark: some students may say we still have another choice, which is girl, boy, boy. No, it is incorrect, since in this choice these two boys are not separated, are seated together, okay? Which is not a case due to a main condition that the boys and the girls are to be seated in alternating seats. At the end of the first session, I advise you to solve many questions around the concepts of permutations. Thanks for your listening.